Hey guys, I'm going to work 11 through 16 on your math workshop, and then we'll get to your notes. Okay, so number 11, 2, and then square root of 361 AB to the third. Sure would help if we knew the square root of 361 is 19. So it ends up being 2, 19. I know a B is to come out, and I should have an A and a B left under the radical because of those odd exponents. 2 times 19 is 38, so my answer is 38B square root of AB. Okay, number 2 is square root of 1058 J to the 9th. Well, 1058 is not a perfect square. Sure would be nice if we could come up with a perfect square number that divides nicely into that. So let's see, I'm trying out 64. I tried out 36, I tried out 64. Maybe, I don't know, something weird like 81. Nope. 16, no. Well, I know it's divisible by 4, we assume. Oh, no, maybe just by 2. Well, that would have helped to begin with. Because I know the square root of 529. That's 23. So it actually is 23, well, 529 times 2. I don't know the square root of 2, but I do know the square root of 529. The square root of 529 is 23. So it's 23 with a square root of 2, and we've still got to deal with that j to the 9th. It's going to end up being j to the 4th, with an extra j in with the radical because of that odd exponent. Okay, number 13 is a nice one. All we need to do is add the exponents with the like bases. So our answer is w to the 9th, x to the 5th. And then on 14, okay, the next one's a little more complicated. I'll actually skip it and come back to it in a second. Let's do 15. 15, if we add those bases, have the, yay. If we add those exponents, because we all have the same base, negative 4 minus 4 is negative 8, plus 4 is negative 4. We can't leave it like that, so it's 1 over x to the 4th. 16, f to the 5th, divided by f to the 11th. When we subtract, so 5 minus 11 is negative 6. But we can't leave it like that, so we write it as 1 over f to the 6th. Okay, finally 14. Let's see. I've got to deal with that negative exponent, but I'm wondering if I could simplify inside the giant parentheses first before I go there. So x to the 3rd, x to the 2nd, if we subtract, we're going to end up having 2 to the x. Y to the 2nd, y to the 5th, if we subtract, we're going to have y to the negative 3. And I can't forget about that negative sign on the outside. And it's all raised to the negative 2. So what I'm going to do is, I could raise it all to the negative 2, but instead I'll just do 1 divided by this whole thing. And now raise it to the positive 2. I punished it, sent it to the bottom, so that exponent's now a positive. And now I've got to raise each of these terms to that second power. Negative 2 to the second power ends up being a positive 4. X to the second power is x squared. Negative 3 times 2 is negative 6. And sadly, I'm not done. I can't leave that negative exponent, so I'm going to have to punish it and send it to the numerator. So my answer is y to the 6th over 4x squared. Now, you could have done this one differently and raised them all to that exponent to begin with. I don't know. I think this was the easiest way to go. Okay, so looking at your notes, 3rd period and 2nd period, you got a little further along the 1st period. So if you want to skip ahead, you can. 1st period was only on number 5 of the complex number problems. Well, actually, they're called imaginary numbers. I haven't even talked about complex numbers. So they're on number 5. So we need to do number 6. I know y'all were further along than that. 6 times 4 is 24. It's 24i squared. Well, just a reminder, because I know you slept since then, you need to know out of the 1st, out of the 2nd, out of the 3rd, and out of the 4th. We explained why each was each yesterday. Miss Brewster has a really cute way of remembering it. It's I, 1, I, 1. So I1. The two in the middle are both negative. But you do need to know those. It's useful to know those. And I said something silly yesterday. I said that your calculator didn't have an I button, but it does. It's down near the bottom. And you can press it if you want to, but it's not going to work out well for you because it's going to give you some weirdo decimal. So unless you're wanting to do like a weirdo decimal comparison of like, does your weirdo decimal match I to the third's weirdo decimal, then it's really still a bad idea. It's best to just know what you're doing. Okay, so for this one, I know I squared is negative 1. So I really have 24 times negative 1, which is negative 24. Okay, number 7, I've got negative 21I squared. Again, I know I squared is really negative 1. So I've got negative 21 times negative 1, which is positive 21. Out of the fourth, that's super easy because I know that's just 1. Well, out of the 11th is our next problem. I always like to think in powers of 4. So like if this was out of the 12th, the answer would be 1. Since it's out of the 11th, you can think of it as out of the 8th times out of the 3rd. Out of the 8th is a power of 4. So I know it's going to be 1. So I'm going to have 1 out of the 3rd. And I know out of the 3rd is negative I. Now that's how I do it. I like to think in powers of 4. I knew since this one was 1 before 12 that it was going to be out of the 3rd. Or in other words, out of the 8 would have been 1. 9, 10, 11, I knew I was going to end up on out of the 3rd. And that's how I do it. But another math teacher told me they like to think in powers of I squared, of the negative 1. So they would say this is I to the 10th times I to the 1. I to the 10th is really I to the 2 raised to the 5th. So they would have said that's 2 to the 5th, so that's negative 1 to the 5th times I, so they get negative I. I think that requires more work, but if you like that, you can always think in powers of I squared. My math teacher just always taught me to think of in powers of 4. Okay, so we'll skip 10 for a second. Let's go to 11. I know 11 is going to be a nice one because 20 is a multiple of 4. So I already know the answer is 1. If you want to like explain it to yourself, like I to the 4th raised to the 5th, 4 times 5 is 20. So it's 1 to the 5th, which is 1. You can, but seriously, the second I see it's a multiple of 4, I know the answer is 1. Okay, number 10. Well, if it was 24, which is a multiple of 4, the answer would be 1. But it's 1 more than that. So again, in my mind, I'm like, 24 was here, so 25 is just going to be I. So I know the answer is I. But for those of us who need it, maybe like this, I know this one's 1, I know this one's I, so it ends up just being I. I'm telling you, I love stuff with imaginary numbers. They're the best. Okay, so if we're going to do math with real numbers and imaginary numbers at the same time, it's called a complex number. Like 2 plus 3i. It's got the real number 2, the imaginary number 3i. So we can add and multiply and do all the normal stuff with that. So, on number 1 on the bottom, we are going to add. Okay, so I'm going to add my like terms. So like I add 5 plus 2 and I get 7. I add negative 7 plus 4i and I get negative 3i. It's just like adding when you have an x in an equation. Number 2, again, just going to work with my like term. So 4 minus 3 is 1. Negative 8 minus negative 6. So it's going to be negative 8 plus 6 is negative 2i. So adding and subtracting is super easy with complex numbers. Even multiplying is not bad. We're still going to FOIL on this, on number 3 with these binomials. So first, negative 6, outer, we get 12i, inner, negative 4i, last, 2i times 4i is 8i squared. Okay, so we combine our like terms in the middle, and we have a negative 6 plus 8i plus 8i squared. But you're smart. We know I squared is really negative 1, so I can replace that. So I actually have negative 6 plus 8i minus 8. So my final answer is really negative 14 plus 8i. So the only cool thing that happens is, I mean, everything's normal in that we combine our two middle terms. But since this is I squared and we know I squared is negative 1, our answer ends up being a less complicated thing. So the same thing's going to happen on number 4. 6 times 9 is 56, plus 12i for the outer, inner, minus 72i, last, negative 16i squared. So I've got 56 plus, nope, not plus, 12 minus 72 is definitely negative 60i. And then minus 16, but again, I know I squared is negative 1. So I actually have 56 minus 60i plus 16. So I've actually got 72 minus 60i as my final answer. And so you were really scared when we started talking about i's and how to imaginary numbers, but I swear they make math just as much fun as it always has been. Okay, go to the back. These 4 are yours. That's how I'm going to know whether or not you watched this video, is whether or not you did these 4. Or you can put a note even. Okay, of course, if we can add and subtract and multiply, we can divide, so we've got a couple division problems. Dividing is the only complicated thing. To get rid of a complex number in the denominator, it reminds me of when we have a complex number in a radical in the denominator, how we didn't allow that, and we used to multiply the bottom and the top by whatever was bothering the bottom. That's the same sort of thing that's going to happen today. So for instance, I got to multiply the top and the bottom by 5i. And so in the top, I'm going to have 4 plus I times 5i. And in the bottom, I'm going to have 25i squared. But hey, I know I squared is negative 1, so I really have negative 25. In that numerator, I can distribute that 5i to both terms. And I'll have 20i. Good morning. Plus 5i squared. But again, I know I squared is negative 1. So my answer ends up being negative 5 plus 20i divided by negative 25. And I'm okay if you leave it there because you should be. You know what you're doing. Or I'm even okay if you had 20i minus 5 over negative 25. It doesn't really matter to me. But I can't deal with the fact that they're all divisible by 5 right now. It bothers me. So I would probably take out a 5. And then you're like, Miss Compton, did you overcomplicate your life? And I think I did. I think I could have multiplied the top and the bottom by just I to begin with and made my life easier. As well. I don't mind doing math this morning. So if I factored out a 5 out of everyone, I would be left with a negative 1 plus 4i divided by a negative 5. And heck, I'm even okay with if you wanted to factor out a negative 5. And so you had 1 minus 4i over 5. Doesn't matter to me. Seriously, I'm okay if you stopped here. I get it. Life's hard. Okay, 2 left. And I swear they're easy, just weird. So what's different between 9 and 10 is that instead of just a pure imaginary number, we have a complex number in the denominator. And so to get rid of 3 plus 6i, we are going to multiply the top and the bottom with a 3 and a 6i. But instead of using a plus 6i, we're going to use a minus 6i. They call it the complex conjugate because it has, it's really the same thing, but a different operation in the middle. So instead of plus, it's minus. So in number 11, since it's 1 minus I, the conjugate's going to be 1 plus I. Okay, so you're like, oh, this stinks. Because if we multiply by the conjugate, now I have 2i times 3 minus 6i in my numerator. And in my denominator, oh my goodness, I've got 3 plus 6i, 6i, times 3 minus 6i. And that just looks terrible. But I swear life's going to work out really great in just a second. So if we distribute with that numerator, we have 6i minus 12i squared. We'll come back to that. I know that simplifies. In fact, if it's killing you, let's go ahead and simplify that. We really got 6i. I know that's negative 1. Negative 1 times negative 12 is going to end up being a positive 12. So in my numerator, I know I have 6i plus 12. Now in my denominator, I'm going to FOIL. So first I've got 9. Outer, that's a 6i by the way. Outer, I've got negative 18i. Inner, I've got positive 18i. And last, I've got negative 36i squared. And no, this was no coincidence. This happened for a reason. When we multiply by this conjugate, the outer and the inner will always end up canceling out. So our answer just has 9 minus 36i squared. But heck, we can keep going because we know I squared is really negative 1. So we actually have in the denominator 9 plus 36. And we know 9 plus 36 is really 45. So our final answer is 6i plus 12 divided by 45. Now we worked really hard for that, so I'm going to stop there. But for those of us who like to continue on, I know all things are divisible by 3, all of those parts. So if you wanted to factor out a 3, and have the 2i plus 4 divided by 15, I would totally understand, but you don't have to be an overachiever like that. Okay, so that's really the hardest thing we're doing today, which is multiplying by the conjugate. So if it's 3 plus 6i, the conjugate that we multiply the top and the bottom by has the opposite sign, so it's 3 minus 6i. And you know you've done it right when you FOIL, and the outer and inner end up canceling out. And furthermore, you know you've done it right when your denominator ends up being a nice, pretty real number, and suddenly there are no complex numbers in the denominator. That was kind of our whole evil plan, because I told you we can't leave a complex number in the denominator, the same way we can't leave a radical in the denominator. They have rules in math, and you know you have to follow them. Okay, so on number, not 12, 12 is yours. On number 11, I'm going to multiply by 1 plus I in the numerator and the denominator. So in my numerator, I'm going to have to FOIL. I've got 2 plus I times 1 plus I. In my denominator, I've got 1 minus I times 1 plus I. I'm going to do that denominator first. We know it's going to work out nicely. We'll have a 1 for the first. The outer is positive I. The inner is negative I. And those cancel out. Our last is negative I squared. But we know I squared is really negative 1. So I've really got 1 minus negative 1, which ends up being a positive 2 in the denominator. So life worked out nicely for that denominator. Now to deal with that numerator, we need to FOIL it out. So first we've got 2, outer plus 2i, inner plus I, and last plus I squared. We combine those two like terms, so we've got 2 plus 3i, but hey, I know I squared is really negative 1. 2 minus 1 is 1, so my final answer is 1 plus 3i divided by 2. That's about as hard as it gets with complex numbers. So if you need to rewatch the part about multiplying by the conjugates to get rid of the denominator, I totally understand. Hope you have a great day. Bye.